Why in a cup of water does a straw look bent when you look at it from the side? And why can you hear someone yell at you around a wall? It's because waves bend when speed changes and spread when they hit an obstacle. That's refraction and diffraction respectively. Refraction is defined as bending at a speed change boundary. Diffraction is waves spreading around barriers or through openings. Let's start with refraction. When a wave crosses into a new medium, for example, sound going from air to water, the speed changes, which means that it bends the wave. Let's say this is the ocean and our sound wave comes in like this. This is the incident ray. And when it hits the water, it refracts. This is the refraction ray. And you can draw a line in between them. This line, by the way, is called the normal. And they both have their own angles. There's something called the law of refraction. It's like Snell's law, but for waves. So, it's sine of the second angle over sine of the first angle equals the velocities in both medium divided, with first angle being the angle of incidence, so the angle it comes in, and always, by the way, you draw the angle from the normal. Second angle being the angle of refraction. And here's the rule of thumb for refraction. If a wave slows down in its new medium, then it will bend toward the normal, like that. If your wave speeds up in its new medium, so if it speeds up, it's going to bend away from the normal. So the angle will be like that. So away if it's faster in its new medium, toward the normal if it's slower. Look at this picture. What is this weird picture? I couldn't bother drawing all this, so I grabbed one off Google, but this is the classic analogy for the law of refraction. These are soldiers marching in a line and they're marching into mud. So this is a straight line. But as soon as the soldiers begin to enter the mud, see, no longer straight line. Also, the ray, the direction they're going in, it's curving as well. See that? Why? Because when one side hits the new medium, the speed changes. And this unbalanced speed means that it curves. This is the law of refraction. And this happens a lot in real life. What about diffraction? Diffraction happens when a wave hits a barrier, a gap, or an object in its path and it bends and spreads into the region behind it. For example, imagine the top-down bird's eye view of a wall in a house. Here's a wall, and there's an empty doorway here. Say Bob, he's yelling like a rabid animal. He's yelling at his mum. And his mum is standing here, trying to hear what Bob is saying. Bob's shout looks like that. But then how does Bob's mum hear him through the wall? The answer, the waves bend outward through the opening, spreads into this room. The rule of thumb is this equation. The angle of spread is roughly equal to the wavelength, so the size of the waves, divided by the width of the opening. What does this mean? Have a look. If the opening is very, very small, then the spread is bigger. Small opening, bigger spread of angle for the same wavelength. Imagine the same wavelength there, but the opening is wider. The spread is minimal. This is a high level diffraction. This is a low level of diffraction. This is why in the forest, let's say these are trees. This is why you can get Wi-Fi and signal. It's worse, yes, but it's because it diffracts around the trees. It wraps around the spreads. So the key takeaway of this video is that a wave hits something, it doesn't stop, it refracts, aka bends, or diffracts, aka spreads. This applies to light, sound, water, Wi-Fi signals, and it's everywhere. This makes studying 10 times easier. Go download the free cheat sheet in the description and I'll include a free surprise worksheet from my premium study kit to help you understand this topic.